Hello friends, today's question: consider a horizontal oriented syringe containing water located at a height of 1.25 meter above the ground. The diameter of a plunger is 8 millimeter and the diameter of the nozzle is 2 millimeter. The plunger is pushed with a constant speed of 2.25 meter per second. Find the horizontal range of water stream on the ground. Take G as 10 meter per second square. So this is a syringe and this is a plunger. Plunge diameter is given as 8 mm and we have diameter of the nozzle as 2 mm, and this contains water. So as the plunger will be pushed in this direction, means towards the right, the water will be pushed from this nozzle and it will be traveling something like this, and we have to find out what will be its horizontal range, means this distance. Okay, let us call this R. So as soon as from the figure we can see, as soon as the water leaves this nozzle, it will be traveling something like a projectile, or the path will be of a projectile. So in order to, we should be knowing what will be the velocity of the water that will be coming right out of the you can say this nozzle. And for that we are going to use equation of the continuity, and that equation of continuity it will be giving us what will be the velocity of the water that will be coming out of the nozzle, and we can pursue then after finding out the later terms using the projectile equation. Okay. So first of all, let us start from there only, that we are going to find out the water velocity at the nozzle. Water velocity at the nozzle. So we are going to use equation of continuity. So you can say from equation of continuity, volume flow rate from the plunger will be equal to volume flow rate through the nozzle. You can say volume flow rate from plunger will be equal to volume flow rate from the nozzle, and we can write it in equation form. Volume flow rate from the plunger will be equal to area of the plunger multiplied by the velocity of the plunger, and that will be equal to area of the nozzle multiplied by the velocity through the nozzle, and where AP is our, you can say, area of the plunger, VP is the velocity of plunger, and we have AN. AN is area of the nozzle, and we have VN. VN is equal to velocity through the nozzle, sorry, not of, but through the nozzle. So it means from the diagram we can say the velocity of the water or the liquid that will be coming from the nozzle will be equal to Vn, and it will be in something in this direction, so this will be our Vn. So let's find out what will be the area. So we can say AP will be equal to pi rp square, where rp is the radius of the plunger and we are given diameter, so we can say this will be pi diameter of the plunger divided by 2 whole square, and we know the diameter, so this will be pi by 4. Diameter of the plunger is given as 8 mm. Similarly, we can find out the area of the nozzle, that will equal to pi rn square. So once again this will be pi diameter of the nozzle divided by 2 whole square, and this gives us pi by 4 2 whole square. and we know the you can say velocity of plunger is given as 0.25. So from the equation we can write velocity of the nozzle will be equal to area of the plunger divided by velocity of plunger divided by area of the nozzle. So we substitute, area for the nozzle was our pi by 4, 8 raised to the power 2 square rather, or we have pi by 4 2 square multiplied by 0.25. Pi by 4 cancels out, so we can write this will be 8 by 2 whole raised to power square multiplied by 25 divided by 100. This comes 4 and this also comes 4, so this 4 goes by this square, and we get our Vn is equal to 4 meter per second. Vn is 4 meter per second. Now we are going to use equation for the kinematics and find out what will be the, you can say, the range. So now the water that is coming from the nozzle will be having a horizontal velocity that is given as Vn, and the water will be traveling something like this. The height which is supposed to travel is given to us, and this height is 1.25, and Vn we just found out is equal to 4 meter per second, and let us call this as range. So first of all we are going to find out the time taken by the water to reach travel this height, that is 1.25. Okay, let's call that as a time of flight calculation. Time of flight, that is given as t. So we can say for a height h, if we call this as height h, for a height h, this will be equal to half gt square, and from here we can say our t will be equal to 2h by g and its square root, and 2 multiplied by 1.25 divided by g we are supposed to take as 10, so this comes as 0.5 seconds. So the water takes time 0.5 second to travel from the nozzle up till the ground. And now we are going to find out the horizontal range, that is R. Calculation of horizontal range. That is our R. In time t is equal to 0.5 seconds. So this will be equal to, R will be equal to the horizontal velocity. So let us call this as V of nozzle in x direction multiplied by time t, and we already know the velocity is projected in x direction, that is 4. So we can write this as 4 multiplied by, we have 0.5 and this comes as 2. So therefore the range, horizontal range, and of water stream on the ground, of the water stream on the ground will be equal to R, and that is equal to 2 meters. So this question was the combination of, you can say, continuity equation as well as the projectile motion. So this completes the question. Thank you.